So one of the benefits of being the second speaker on the same subject is that you're going to hear it all again. So thank you very much. Any questions? No, fortunately, we come at this from completely different angles, which is kind of nice. There is some terminology that you'll see again, unfortunately. But we tend to get a lot of our work in and around the analytics and growing analytics from kind of small beginnings through into using some of the frameworks that we've been discussing. So we can kind of, when we get to the questions, talk about what things mean in the larger context. The book on your right, my colleague Ken Collier has written a book called Agile Analytics, and it's become a bit of a become a bit of a Bible for us internally at Thoughtworks. We've built an engagement model around it, and it's become a really convenient and adaptable way of working with people to work with their problems and their data sets. And I've got an example at the end about how we actually do this stuff. So I'm Dave Elliman. I work in the global CTO office for Thoughtworks, and I also at the moment run big data analytics in the EU. We all tend to have a bunch of jobs. So I'm also the market technical principal, which is the head of technology for the UK South as well. So I am beholden to give you a bit of spiel about Thoughtworks. I won't do it for very long. So because you're celebrating your 10-year anniversary, we're celebrating our 21st. We kind of got involved in the whole Agile movement big time in the early 2000s. Two of our guys, you must have come across the works of Martin Fowler. He still works for the company. Jim Highsmith, another one more kind of on the business side. Two of the 11 signatories to the Agile Alliance, and CTO Rebecca Parsons still chairs the Agile Alliance. So that's still very much our kind of bread and butter. But we have three pillars to our company. The first one is exactly like any other company, you just got to run a sustainable business. The second is to champion software excellence and revolutionise the IT industry. That sort of sounds like a lot of rubbish really, doesn't it? But it's actually true. We take it really seriously that what we want to be able to do is to try and find the most appropriate way to do stuff and innovate, because that's what turns out that's why we work for Thoughtworks. It gives us the opportunity to help people to find not just the best fit solution, but something that we can actually innovate and disrupt the industry. The third is equally important, is that we are big advocates of social and economic justice. So we will do a mixture of work, either supporting open source projects or doing limited rates work by trying to support communities in the Global South, for example, and making sure that when we build a business model within those countries, the money stays in that country. We take nothing from it. The owner of the company was still owned by one guy. He takes no money from the company at all. He's not interested in profit, and takes all of the profits that we make and puts it into social and economic justice. So, yeah, as John said, there's a bunch of us all over the place, whatever. We're big into this whole sort of software excellence piece. We've written over 60 books. We published semi-annually the Technology Radar, which I presented in London last week. It is a common talking point for us. A number of people know us through our Tech Radar. If you haven't looked at it, it's like on the front page of our website. And we're strong advocates of open source. So if we get to the point where you want to ask me about anything to do with any particular software products that we might use, especially in this space, we'll be trying out the open source ones first. Yeah, so we do some stuff. Right. It's fun. I'm pausing because for this slide, I said to John earlier, I've got some really interesting statistics about data growth and whatnot, and I never get them out. But we've all heard this whole thing about a data or an information explosion. And it's around the fact that there's more mobiles than there ever have been, more devices in different contexts, the whole social media revolution. In fact, kind of what Andy was saying, that we've got this problem, where we've got more data than we can currently, or certainly before the last few years, have been able to cope with. So the big part of it for us is kind of misleading. So we're sort of coming at it from a slightly different angle. So yeah, 3 V's, here we go again, bit of repetition. We've got some volume, got some velocity, and we've got variety. Now, we tend to find that variety, to the point the gentleman made over here about unstructured data, we tend to work in that space a little bit more. Data's really messy. It's quite often the case that within a project, somebody will talk to us about a particular problem that they have. They want to know something about the business or a series of things, simplifying. Or it may be, we get some cases where somebody says, do you know, I know that I've got some value within the data that I have, and I don't even know what questions to ask, so we have an engagement model, more of a discovery, where we go and actually help them to understand their data. But we spend over 3/4. I think that the commonly bandied about statistic is 80% of time is spent on data cleansing. We certainly spend about 3/4 of the time. It's obviously up front, because you're trying to work out where the data sources are coming from, which systems the company has. And it can really vary in terms of how you choose to address it. But when you understand the world of data that you're dealing with, it takes quite a lot to pare it down into something that's actually useful. And obviously, the world's changing. Everything's changing all the time, because the amount of technologies that we have at our disposal is changing all the time. The storage mechanisms, the ability for us to query, the questions that might have been alluded to about Hadoop earlier on. Hadoop is now a bit of a different beast than what it was just a few months ago. But there's still not many people taking full advantage of that just at the moment. And a lot of companies that have to make use of data have got a shrinking life expectancy of their own. We expect companies to either make competitive advantage out of the data that's available to them, or they're going to suffer for it. We do a lot of work in the retail space, and within retail, the big thing, quite clearly, is personalisation. So personalisation, what does that really mean? To most people, it's probably the fact that you get spam mail or something like that. So there's a CRM system sitting somewhere that knows something about you, because either you've registered with the site and it never lets you go. So that kind of blanket information has been the sort of like the personal engagement model for the last few years. Now, you know as well as I do that you go onto Amazon or something like that, and it's a very different thing, because you'll get recommendations. So there is something sitting there that's trying to give you some information that's relevant to you. So doing something like that, you know that it's not just about the fact that if I ordered a book about fishing, that I'm going to get presented with a picture of a fishing rod. There's a little bit more to it than that.
No, it usually offers you more books on
Fishing.
and you get more of the same.
Right, can I just nick this? Cheers, thank you. But certainly with different data sources, trying to make some sense out of it and trying to get something contextually relevant is something that we are focusing more on. So we know that we've got a big problem with data. We know that we've got a scalability issue. But this is really where we see most people coming to us with problems. They don't know what to do with their data, and they need people to try and work through it in one form or another. So we also know that the industry tells us that big data, whatever that is big business. And there are various predictions to say it's going to be worth this much. The industry is going to be worth this much by this date. And there was a report I read, I think it was just before Christmas. 64% of companies, and forgive me, I don't have the source for this, but from the sample that was taken, 64% of companies said that they were about to start a big data initiative. But 8% of them, 3 months later, had not done anything about it. So it's like, Andy made this sort of similar point, that, we all talk about it. Sorry, it was John, wasn't it? We all talk about it. We don't really know kind of what we're doing with it. So a lot of people are kind of in that hinterland. You get people that have engaged and are actually working through this, and a lot of people that haven't. It's messed up my fonts. A lot of people coming to us now with problems around disparate devices. We're getting a lot of interest in India and, funnily enough, in Scandinavia for what's commonly called the Internet of Things. So, given the fact that when we sort of talk about devices, back down here, this sort of represents broadly the number of people and the number of relative devices, and obviously you're seeing that reversal to the point where it's actually 26 billion devices are predicted by 2020 globally, which far outstrips the number of people that are going to be expected to be on the planet at the time. So for all those devices, all that data, so obviously, I'm not going to necessarily wax lyrical about the obvious amount of data, but the point was made by Andy about the veracity and the correctness of the data. It's funny, sometimes when I talk about start off with the 3 V's and a bit more sort of gusto, I introduce 2 more, and the veracity is one and value is the other. And for me, value is the actually only thing that's important with any of this thing for what we need to do with customers. And here's a great example. I have 2 references to agriculture in this talk, and this is one of them. One of our clients came to us with a problem. They needed to have a system that monitored cows. And there was some research done in Sweden that said that given particular behaviour from cows, you could predict certain things about their readiness to become pregnant and then milk and so on. So we're building some devices that monitor the vital signs of a cow. And did you know that the way a cow walks can predict whether it's ready to become available to become pregnant, or indeed it is pregnant, the distance that it walks and the patterns that it creates in the field. So, given that type of analysis, whatever that is and whoever's done that and wherever that's come from, it's a very different way of thinking about a particular problem. So it's not really in the same world as being able to take this data and construct some form of querying model over it. It's a totally different thing. We have to get some very context-specific analytics that some experts within that field have come up with. They have a theory and a hypothesis, and we have to give them a framework and an ability to get that data that's going to be, in this particular case, it's not that dirty because controlling the actual distribution, the origins of that data. But very often in cases where you're dealing with multiple devices and sensors, there's all sorts of things going on. Unreliability of the actual source of the data as well. Walking patterns of cows, up and down, you can tell well, they're actually going mad. So really we're looking at a completely different sets of things. And here's my second farming reference. This is a thing that happened a couple of years ago, which is actually, for me, was one of the most interesting things. In May 2010, there was a record heat wave in Russia, and followed on by some crop failures. Again, following on from that, there were some wildfires that resulted. In August 2010, the Russians stopped selling grain reserves. I'll come back to that. That led to global increase in food prices, and then an increase in oil prices, and harvesting costs increase in the US, obviously because of the running the machinery. So that's a sort of a natural sort of linear phenomenon. That's a bunch of things that just happen to occur, so certain causality and certain correlations there. There we go. So there are events, in this case, that's uncontrollable to do with weather, geopolitical events. So when Russia stopped selling grain reserves, it's said that that happened because of a lot of social pressures that were mounting within Russia and social media at the time. So the ability for people to start talking about this in the social media that was present at the time is said to have influenced the political decisions. Now, given the presence of social media in this case, it's hard to know quite whether that's true. But one thing that came out of this particular series of events was that a university in Australia picked up this series of scenarios, and there's some specific data sets that were recorded, and have now built a predictive model for predicting wildfires in Australia, which is a problem that they suffer greatly from. So to try and prevent natural disasters, something potentially good came out of this. And to push the point home about different types of data and the types of analytics, there was a study done that we were tangentially involved with from the University of Rochester in New York, a guy called Adam Sudderleck. And he wanted to run a predictive model about the speed at which people catch the flu and to try and track it through the boroughs of New York. Now, the thing with this is that, so there were 6 million tweets, 6 million tweets from 633,000 users, I believe. The thing with this is that you can imagine that, like building something that is a receiver of tweet data, building some sort of real-time analytics, which might be something that Andy touched on. You could put something like Storm in place that might be the thing that might do the analysis of that and put some analytics. But that's the thing. What analytics do you put in place to do that? Because the problem with that is that a tweet might say, I'm sick. It might also say, somebody might be skateboarding and say, that's sick. How do you know the difference? So there's a lot of natural language processing and context-relevant stuff that's in those tweets. Now, they actually got the predictive model down to, they could predict 8 days in advance the particular areas where the flu was going to be hit with a 90% accuracy. So doing that is not just about simply receiving the events and putting some fairly basic program in place. It's about taking the analytics that are very, very domain sensitive and trying to find a way to get them in a framework that can deal with the data. So we tend to think of it through where's your problem, what's your value, and how do we build up to the fact that we've got to cater for the big data side of things. So it might be about dealing with samples of that data initially. Final example, before we dive into something where we actually did some example of our analytics. Early breast cancer detection. Each year, 1 million women are diagnosed with breast cancer, 400,000 of which will die. Most of the time, when a woman has a mammogram, they don't tend to do mammograms under the age of 50, for a start. From the ages 50 and above, the 10 to 12 year period is when it can be found. An expert mammographer apparently can find it at around the 10-year mark, but they tend to find it around the 12-year mark. So between 11 and 12 years, you notice, I don't know if you can see this, but the thing can be about 4 centimetres. They double in size every 130 days, and it takes up until these points where they start to become noticeable to inspection. So a company have come up with that. It's a sensor bra that women can wear, and they think, in actual fact, if I take that back, that the company First Warning, they can actually detect the presence of cells that may result in being growths much earlier in the process. Now, there's deliberately no actual dates in this because it varies too much, but you're looking at something that's way, way earlier, and they're looking at drastically reducing the amount of time. So the bra, it's just a device. It sends data. There is a system at the other side of that that's analysing the output data. So you wouldn't say necessarily, is that a big data problem? Well, it's a spectrum. The whole big data thing is more about the opening up of opportunities and freeing us away from previously either siloed forms of analysis that were done maybe in universities in science, taking those out and making them available to other forms, because things like the Internet of Things, which is the devices being available over HTTP, for example. So that technology gives us, Wi-Fi gives us the ability to house these analytics in such a way that we can then make use of them in way different contexts than we ever have before. I'm going to brush over this particular one. This was just to give an example of the speed, the velocity side of things. This was one study that was done where it was noticed that people who look up restaurant information from a normal computer could be looking for something at the weekend, days hence. Whereas people that look at it on a tablet, it's usually within that day. They want to make a booking. If it's a mobile, they'll want it immediately. Finally, the US elections became known, I think 2004 was known as the blog election, 2008 was the social media election, and 2012 was the mobile election. And basically, some interesting statistics came out of some usages of mobile apps that started to tell us some interesting things about people and their willingness to use mobiles within different contexts. Yeah, this one. I thought this was pretty funny. Republicans listen to Kenny Chesney, George Strait, and Reba McEntire, which is great because I've never heard of any of them, but apparently Democrats love them. Republicans, rather. And Democrats listen to Rihanna, Jay-Z, and Madonna. That's got to be funny, isn't it? Honestly. And this Pandora, it's like Spotify. But what they did with this was they used a system to recommend specific adverts to people. And I think the budget, it was some ridiculous number of $1 billion for the budget for the promotional campaigns, but 54 million was spent just trying to target people to vote through these advertising campaigns. Yeah, whatever. Okay, so the point here really is that what we're looking at is that the data that is generated by all these things, when it comes back to us and what we do, it's about how we integrate with our world. There's some interesting stuff. I was with Tim Bray today, Tim Bray of Google, who's worked in Android and also with on Google Glass, and another thing that I'm not allowed to talk about that's kind of in the same vein from them. And they believe, Google believe collectively, that the future is around the point that I made at the beginning of this, is around personalization. But that personalization is about the way you interface. Sometimes people call it the blurring of the physical to the digital. It's just about your ability to have something that fits more cleanly into your life than potentially a handheld device and enables you to interact in different ways. And then fundamentally allows them to sell you stuff back through the same way. That's what it is. So how do we create value from data? I'm going to go through this. I'm running out of time. I think I'll go through this quickly. So we have sort of external and internal forms of data and internal and external users of the data. So examples that we've kind of touched on is that market basket analysis. Well, that's one example of something that we've done. You know, I saw a few badges from banks in here. That's the kind of a certain very fixed structured analysis that requires certain tools, not dissimilar to what Andy was talking about actually. Inventory planning, fraud detection, customer behaviour. And then contrast that with this type of stuff, fitness tracking, personal finance management, personal task analysis. They're very much about you and the way you want to live your life. So traditional enterprise analytics tends to cover off all of that stuff. And really, the crescent of opportunity is the ability to handle all of that other stuff, and that's just mess. All of that is lots of data and lots of mess, and you have to write specific code to process it, and you have to put specific domain local analytics in place to use it. So I love Gartner's hype cycle. Whoops. I don't like a lot of Gartner stuff, but this is funny. I like this whole trough of disillusionment thing. So, you know, big data's like way up there on the hype cycle, internet's just following it. We're kind of like building up in the excitement and you know, it's about to go down the trough of disillusionment or despair. When we look at the tools, it's interesting that predictive analytics is now kind of out the other side. We're now starting to see some, you know, we've built it up, we've torn it down, and now we're making some proper use of it. Web analytics is like everybody's using web analytics and has been for a while. Social analytics, well, we had to because the social platforms are so huge. We've got to be able to make use of these things. Text analytics, that kind of like plays back to the Twitter example. And then predictive modelling solutions. So I'm going to talk a little bit about that. Now, so I love this picture. So we've got all these problems, new skill sets, new infrastructure, different architectures, technology choices, data scientists, we haven't got to them yet. Which data sources, needles in haystacks, business demand, and then the most important thing, as questions evolve. So it's no longer hard to find the answer to a given question. The hard part is finding the right question, and as the questions evolve, we gain better insight into the ecosystem and our business. So Kevin Weil is the analytics lead at Twitter. So what is Agile analytics? I've taken a long time to get to that, haven't I? So really, it's about taking an idea, envisioning something that you need to know from your business. If only we knew X, we could do Y. How would we go about doing that? Well, we often go and engage in some discovery mode with people. And we'll use a number of different techniques. People often assume that you will take one way of modelling a business or one model to use in either recording the business if it's sort of descriptive analytics or if it's trying to do a prediction. There is one model to rule them all for that business. It's not the case. You'll often put a chain of things together. Very often we'll use certain techniques to clean the data. Certain genetic algorithms, for example, are very good at actually paring down and taking meaningful samples from data. So we'll talk to people about what's important to them, and then those decisions can help us to get the models or the chain of models in the right state. And it's not like, let's do a piece of analysis. Okay, that's your answer. It's a constant discussion and a daily adjustment to what we're doing and how we're doing it. I mean, that's the Agile thing about it. It's all about test and learn. We'll do something, we'll try it out, we'll sit with the client and with the experts, and we'll work out what it is we've actually got, and we'll work out what it is we're actually providing. So the idea being that you can take whatever that data set part is, usually a sample, and create something from it. It's got to mean something. If you do this within a day or two, and we're usually talking that we'll rock up on a site, analyse the data sources within a day or two, and by the end of day 2 or 3, we should be finding something out. Usually relatively simple at that point, but it's usually similar to problems that we've seen before. So the key point here is don't think big or go home. Instead, focus on the repeated learning cycles and constantly evolve. And when you get to needing to worry about big data, as in the classic example, then do so, but don't do it at the start. So start with your ideas, do multiple experiments, potentially in parallel, and be prepared to change your mind, can an idea, and then when something works, double down and keep going with it. So very quickly, this is how traditional analytics works. There's all these stuff that you need to do. Discover, harvest, filter, integrate, augment, analyse, and act. That's a really hard thing to do in that sort of short time frame. But typically, when we look at sort of traditionally data warehousing things, the leading time to doing all this analysis is very similar to sort of waterfall software design. 3 to 6 months, then 2 months of stuff in augmenting and analysing, 2 to 4 months of actually acting at the end. Well, it's often too late. I mean, you can't do that now with the way that the business models and the data rates are changing. You just can't work like this. So we have to try and find a way to do the kind of same thing, but in much smaller ways. So we'll do everything we can to try and take a question, work through whatever we can as quickly as we possibly can, getting all of the different stakeholders that would be involved in that linear process together as a group of people and work through a problem really quickly. And once we've done 1 or 2, then it starts to get a little bit easier and easier. And some of this flows a little bit more. So one example, just to sort of like come towards the end, Chicago City Services asked us to help them with their emergency services. They had problems with allocating ambulances adequately. So they asked us to try and start off by look at their world so we can actually have a look at their existing data and tell them back how they were performing, etc. They hadn't really got anything that modelled their business. And then help to forecast a better way potentially of working or allocating resources. So we started off by Has anybody used any analytics tools such as R at all? Anybody familiar with the R platform? Some nodding heads, jolly good, marvellous. Okay, so we had a fairly long discussion about the type of thing that would be applicable given the data set. And one of our data scientists said this feels like a fairly standard time series analysis. So we looked at various ways of various models that one can apply within a time series analysis context. We used an autoregressive integrated moving average. For that moving average, that gives us some idea of taking random samples of data and being able to make some sense out of it. Then to make some sense out of it, we broke those time series elements down using a singular spectrum analysis, which kind of discretizes it and gives us the componentized parts. And then we used a smoothing function. Holt Winters is basically an interpolation model. But whatever that means, it just gave us the ability to look at their data and try and give them back a picture of what they actually had. So when we gave them an idea of this is what your data looks like, we could then take that and very quickly build a forecasting model out of it. So if you look at something in the past that's known, take your forecasting model for what you expect in the future, you can backtest it by sort of saying, oh, well, if I had the data and rewind back a year, and then, the financial guys, you'll know it's backtesting, you can then reapply it and then see where you went wrong. And then you get an error function, the residuals. You can just adjust by the residual, so you can apply an error function. So that gave us the true distribution, which is the red line. Then the fitted distribution was how close the forecasting function was. So to enable us to forecast, we used a Monte Carlo simulation. So Monte Carlo simulation, to anyone that doesn't know, it's kind of like if you had an inordinate amount of possibilities and quite a high number of parameters that you could adjust. You've got a massively combinatorial sort of series of paths you could take through a problem. So what can you do to do a few of those, and by a few I mean quite a lot, but still, much less than you would potentially, need to do to fully qualify and do the naive solution, do absolutely everything, and get some meaningful idea back out of it. So we ran this, and we tried to feed in some criteria into it, and we did this sort of over a series of iterations. By feeding in some queue of occupied units, which was when the ambulances arrived, it was what the queuing would be for available sort of the equivalent of A&E sort of like beds. We imposed staffing constraints on it. We put a tolerance of no delay of 90% of the time, and that whole thing that I've just described, that whole processing the data, building the models, looking at the data, that took 3 days. So we're looking, and this was gave them a picture of the ambulance call-outs rates throughout a day. So that gave us the ability to get very quickly to the heart of a problem, and even though they were dealing with reasonable amounts of data, that wasn't a sort of a big data problem, but they were interested then in rolling this out and using it in a real-time basis. So finally, data scientist. What's this guy got to do? Well, we know about machine learning and all these things that we hear about that the guys have to do. It's fundamentally sort of a cross between a mathematician, a statistician, and with some programming skills. And anyone that's worked with any quants in the room knows what a challenge they can be. And this is really no different from that. So Agile analytics, and this is the final slide, is kind of all of these things. It's all the world of big data, dealing with all the technologies. It's how to create the right solution. Something we've not touched on, but it's very dear to us, is the ethics of this, privacy of data, being able to make certain things available. Someone asked us to do demographic relationships of data, IP addresses to postcodes to demographic lookups. Sorry. Continuous delivery, that's another subject, but it's a way that we try to do things such that when you write code, you can deliver it to production repeatedly, like multiple times a day. And the same idea applies here, that whatever we're doing, we're writing code interactively very often, and we'll deliver it into production all in front of the users all the time. And that's pretty much it. So taking the analytics, applying lean learning, agile, and getting it out there, building it up from the ground up. That's it. Any questions? I need just as many questions as Andy, right? just saying.
Well, here's your first one. Speaking to someone who's trained as a scientist, what worries me about your approach is that often the best ideas in science comes when the mind is relaxed. It's a known fact. And my experience of the Agile process is that it's a very much a churning process, very quick time process, as you've said. And it's often extremely difficult to get very good ideas in that context because you feel constantly under pressure to be able to do the next thing, the next short-term thing. In academia, we had a similar analogy where there's a publish or perish culture,
right.
Academia.
Yeah.
And that created, academics felt under such pressure.
Yeah.
To churn out results.
Yeah.
That they were producing a lot of paper which was very mediocre.
Yeah.
And in America, they found that sometimes it was the semi-retired guys who had a chance to really sit back and think and weren't under that pressure, producing big research. Do you see this in your analysis, or do you think it's going to be a problem?
So I'm tempted to say, well, no, but you'd expect me to say that. Part of it is because with an agile process that's done properly, it's about putting certain things into place that can take a lot of the kind of drudgery away from you. So when you write some code, then having automated tests in place, having some automated delivery of your code to live, doing the live tests, it's something you put in place at the top of the project to make everything as easy as it possibly can, such that when you are able to work quickly and iteratively, a lot of those kind of problems go away. So therefore, you can get to concentrate on what it is that you need to do. Now, to directly answer your question, what we try to do with these types of problems is start with the simplest, or it's either what's your hardest problem, and then we'll kind of break it down, or what's your simplest problem, and we'll work up. But the actual process of iterating over a problem domain usually comes very naturally, and in fact, people get used to it, and they're actually like wanting to work, many times, iterate multiple times a day. And we find that the speed of iteration usually comes from the client rather than some imposed boundary that we say, oh, we're doing Scrum and therefore we push this every week or some rubbish like that. Yeah, I don't know if that really answers your question, but I think it's a different experience than what you expect. Having said that, some software delivery projects that work with people that are only used to, some creative people in creative design, for example, they will take 4 weeks to do a design. And they actually only do the design on the last day when they've thought about it for 3 weeks. So it does sometimes take a bit of a mindset change, but when people kind of get into the flow of it, it becomes something that isn't a challenge.
Okay.
I think it's probably something you've got to maybe go through, then take a view.
Fair enough. Yeah.
Anybody else?
Hello. My question is basically around the reuse of models. So basically, if you found a solution that works in a particular domain, is there a mechanism or process that would say we can apply this same model solution to a different domain? Or maybe
so I think that. So I don't think there is an answer to that. I don't think there is a way that you can reapply. I think it's exactly the same as if you've written a piece of software for a problem. Your ability to reapply that software in a different context. If it's exactly the same, then you can reapply exactly the same thing. But very often with analysis, either the ability to get the data into the analysis piece has got to change, or something that you do with the model. The actual processing the model is usually, in terms of code, for example, is trivial. It's deciding which ones to use and how to, if they're parametric, how to drive them. That's really where the challenges are. It's more about what you do rather than sort of how you do it.
So something like Monte Carlo simulation, you could apply in another context, for example. Oh yeah, absolutely. So yeah, thinking like that. Yeah, I mean, there are a bunch of things that
it's like, what are the tools that I've got in my toolbox? What's the problem? Which ones will I pick out and apply in this context? Yeah, so you will, you're not doing everything from the ground up, from first principles every time. No, not at all.
When you're performing analysis for a customer, have you come across a situation where ethically you've uncovered a situation or information that the customer, that you don't feel you would like to pursue, but that the customer feels is their right to know because of the engagement with yourselves?
Right, so if I understand you correctly, have we uncovered data that the client wants to take advantage of?
Ethically, like you said that ethics was a major part of your company.
Yeah.
So have you performed analysis
Yes.
on, say, a customer's data
Yeah.
that then you suddenly realise that ethically, perhaps as a company, you wouldn't want to pursue, but that the customer felt was part of the engagement and their deliverable?
Right. Understood. At the moment, no. And the reason why we haven't found that particular circumstance is because we qualify people out. We're a bit fortunate and a bit weird in a sense that we tend to be sort of oversold. So we can be slightly selective. I mean, it ebbs and flows like most businesses, but by and large, we can sort of select the types of things that we choose to do. So it's usually relatively obvious, like, within a single conversation, what the domain and the context is and what somebody wants to do or wants to know about their data or their problem space. So we haven't specifically seen that. But have we qualified people out early? Yes.
One more. Some quiet, eh? Yeah.
So something you said got me curious about the corporate sort of life expectancy. I think you were talking about actually life and death of companies. But in terms of the life expectancy of your projects, we've seen so much innovation and the big data space is moving so quickly. An example you gave the Chicago hospital. It sounded like from that initial engagement, there was some analysis that they wanted to kind of turn into a solution, a thing that you would presumably build for them and give them. Have you found it challenging in those situations, given how rapidly the so-called big data landscape is evolving, to actually deliver a technically sustainable solution to a client?
That's a really good question.
Thank you.
Yeah, actually. I think we find a number of challenges. Sometimes the analysis work works so well that when you try to scale it out to use some of the larger tools, I don't think we don't tend to find too many problems with us using them, but there tend to be logistical problems and cost problems that people don't always expect. So we have to have those conversations with people up front. So that sort of conversion in terms of an engagement model from the kind of initial data analysis and then growing it into the bigger, more sustainable thing is a problem. But you were alluding more to the speed of growth of the technologies maybe and how that space is changing.
Yeah,
so
technology you might deploy today.
Yeah. So one thing we actually make a real point of doing all the time is getting them to prepare to pivot their sort of choices. Now that's easier said than done. But because we will go in with that expectation up front, then there are cases where you kind of know that it fits a particular problem. It's there, and it might be the case that what you do is you might swap out a data store or something like that, or it might be the case that you do use sort of a Hadoop, or you go with more of a sort of an event stream processing solution, something along those lines. And I think that when you stay with the more sort of, because we're a bespoke software company, when you stay within the realms that we're more familiar with, it's much, much easier to change. So if we're doing something with, software that we write, then as opposed to products that you select and recommend, it's much easier for us to deal with that change ourselves.
Right, thanks, Dave.
quite a lot to take in, wasn't it? In 1 hour, we've all done very well. I think that sort of wraps it up for this event. Please stay afterwards. Regarding you two, I recently asked a client of ours what it takes to sort of, what they look for in their people, and he said, John, it's fairly simple. We look for people who are smart enough to know what the right thing looks like, and passionate enough to do the right thing and knock down the doors in the way that they want to be knocked down, and never stop wanting to make things better. You two have it by the bucket load, and I can see why your companies hold you in such high esteem. A massive thanks to both Dave and Andy for their very insightful presentations across big data, and two completely different presentations is to you guys. Thanks very much. Finally, a massive thank you to all of you guys, to our clients, to our candidates, to our advocates. Thanks for your belief in us. Thanks for your trust in us, in the way we will never change the way we do stuff. And for us, it will always be quality over quantity. So that wraps it up now. Stay behind. We look forward to seeing you over the next couple of hours. Thanks, guys.